Hey everyone, it's me, Lance Montero, and in this video we will be discussing about titanium dioxide, which is a kind of engineered nanomaterial made up of metal. We will start by learning what it is, how it is fabricated, and also its specific features. But more on that anon, because we must first need to understand what nanotechnology is all about. So, what is nanotechnology? Well, nanotechnology, or nanotech for short, is basically the study of manipulating matter on an atomic and molecular scale. Generally, nanotechnology deals with structures sized between 1 to 100 nanometers, and it involves developing materials or devices within that size of range. Now that you have a slight understanding of what nanotechnology is, we can move on to our main topic, which is titanium dioxide. So, what is titanium dioxide? Well, titanium dioxide, or also known as microcrystalline titanium dioxide, are particles or dust with the diameters of less than 100 nanometers. They are an inorganic compound that mostly appear as a fine white powder. It was actually first discovered in 1791 by a British clergyman and mineralogist, William Gregor, and this powder was mainly used for art because it is depended on for its non-toxic, non-reactive, and luminous properties. We're now onto the fabrication process of titanium dioxide. There are actually various methods that can be used to fabricate titanium dioxide, but today we will only focus on the ones that are commonly used, in which this includes the sol gel process, the chemical vapor deposition or the CVD, and last is the hydrothermal method. First up, we have the sol gel process. The sol gel process is a wet chemical technique that is mostly used in the field of material science and ceramic engineering. It can be defined as the conversion of a precursor solution to an inorganic solid through polymerization reactions induced by water. Next is we have the chemical vapor deposition. The chemical vapor deposition, or the CVD, is a process in which the substrate is exposed to one or more volatile precursors, in which react or decompose on the substrate surface to produce the desired thin film deposit. And now onto the last method, which is hydrothermal processing. This kind of method refers to the use of an aqueous solution as a reaction system in a special closed reaction vessel to create a high temperature, high pressure reaction environment by heating the reaction system and pressurizing it, or the vapor pressure generated by itself. Now, before I end this video, we still need to discuss the specific features of titanium dioxide. Titanium dioxide has a number of unique characteristics that makes it ideally suited to many different applications. It has an extremely high melting point to 1843 degrees Celsius and a boiling point of 2972 degrees Celsius. Titanium dioxide can also absorb UV light. This property makes it appear bright white under light, unlike other white materials that can look slightly yellow. Importantly, titanium dioxide also has a very high refractive index, which is the ability to scatter light, even higher than a diamond. This makes it an incredibly bright substance and an ideal material for aesthetic design use. Another crucial property of titanium dioxide is that it can show photocalyptic activity under UV light. This makes it effective for environmental purification, for different kinds of protective coatings, sterilization and anti-fogging surfaces, and even in cancer therapy. So to summarize this video, titanium dioxide is brilliant, resistant, protective, and powerful all at once. And this will be the end of our lesson. I hope you learned something from this video and thank you for watching.